I know this is something you guys talked about before when in geometry. In geometry, when you guys talk about the angles of elevation, angles of depression, you probably recall going to the auditorium and measuring things out with a clinometer and a straw. That's what you were doing. You were using.
Let's do it again.
Yeah, you were using actual crude tools to measure out the angles. You were figuring out distances and stuff like that. Of anything that you guys ever learned in geometry or you use on a pretty regular basis in the normal world, it is right triangle trig with elevation depression, because you can measure distances. If you ever see surveying crews where you got the guy looking through the site, the guy holding the stick, they're measuring, I mean seriously, that's what they're doing. They're measuring distances and going through it. If you've ever seen Indiana Jones, when he goes into the temple of something and he holds the staff of Ra, and the sunlight shines through the crystal, and it shines upon where the Ark of the Covenant is being buried. That's an angle of depression in which it was refracted through sunlight and re-shown through. But hell, it's still an angle. It's neat. Love that movie. So, my kids love that movie. It was great to show my kids. Loved it. So remember, angle of elevation. Elevation, think of it this way, is line of sight looking up. And what I mean by line of sight, what I mean of line of sight is your eye level. That's what it means by line of sight. So a lot of times, depending upon styles of problems and whatnot, you could have to compensate for eye level. That's what you guys did with the clinometer stuff that we did down in the gym, or in the auditorium last year with you guys. Did you guys know that that was a lesson that Seb and I wrote back in college? 12 years ago, we gave that presentation to our class in college, and we got, I think we only got a B on it. No, we got an A on it, but yeah. We have not changed that lesson at all. But yeah, that's about it. Well, yeah, we use the exact same diagrams, the bad pictures and all that, the write-up. It's the exact same thing that we wrote up 12 years ago in college together. Pretty cool. Anyway, so line of sight looking up. So it's your line of sight looking up. Remember, line of sight is always parallel to the ground. So it's your line of sight looking up. And that gives you the value here of theta. It's what you're looking at. Depending upon what the problem is talking about, it might talk about shade. Like the shade of a tree is so far from the base. How tall is the tree? You know the angle, that kind of stuff. Now, angle of depression then is the opposite. That's line of sight down. Line of sight looking down. Now, if you think about it, go back to my happy person. Not drawn to scale. You might have. Line of sight looking down. That's this angle here. Line of sight is always going to be parallel to the ground, which means if the height here is your overall height, the angle of depression here, since these are parallel, is the same as the angle of elevation looking back. It's a very common thing. Angle of depression is used for like a lot of aircraft style problems because they know what it's looking down towards from its flight path, if you will. It knows that angle looking downward is something, and it would know its vertical height because it knows it has a thing called an altimeter, altitude meter, and you can figure out how far away you are from something. Did you know that? No. Knowledge. Merry Christmas. All right. So what we do then is we can use. Where's my car? Just downloaded it too. We can do stuff like this. The angle of elevation from a point 116 meters from the base of the Eiffel Tower to the top of the tower is 68.9 degrees. Find the approximate height of said tower. Do we know where the Eiffel Tower is?
Paris.
It's in in Paris. No, I just got a powder in my nose. Clue right. Have any of you been to said Eiffel Tower? Yeah! Wasn't it awesome?
Yeah.
I like it. That's really cool. It's so cool. I would go back to Paris in a heartbeat. We were there for like 3 days. My brother and I did a tour of Europe. It was just not enough time. So, angle of elevation is from line of sight looking up. Well, this one doesn't say that there's a person standing 6 feet tall looking up to the top of the thing holding a clinometer or anything. It's basically saying, hey, knucklehead, from the ground, looking up to the tower. See how well I can draw that.
What the heck? Are you sure you went to see it?
That's pretty close to the Eiffel Tower.
How would you know? Yes.
Yeah! How would you know? You haven't seen it. Sorry, it's black, not blue. How about this? Not the scale. So if this is 68,
He draws up asterisk, not drawn the scale.
what trig function are you use to find the approximate
That's
height?
like doing all my tests.
Which one? Tangent. Very good. So a lot of times you might have noticed this, or you might remember this from last year. A lot of times when you're using angle of elevation, depression stuff, you're probably going to use tangent. The reason why you wind up using tangent a lot more than the other ones is because, generally speaking, you can throw a tape measure horizontally or a tape measure vertically. It's very difficult to measure a distance on an angle with a tape measure. If any of you ever used a tape measure, if you start fishing out a tape measure more than 6-7 feet from the tape measure, it just goes and falls over. So that's why we usually measure horizontal or vertical distances. So you'd use tangent. So the tangent of theta, or in this case 68.9, is equal to your overall height divided by the 116. Well, it's a real quick one-step algebra problem in this case. You multiply both sides by the 116, and you get the approximate height in meters, because they are French, so they speak in that was German. When we are French, we use the metric system. The metric system is important in France. You think my Spanish, hola, como está usted, is bad. My French is much better. I get to get the curly mustache and talk about paintings and impressionism.
Sorry. No, I was laughing at Braden, not you. So.
No, that's all right. I'm laughing at myself too, so it's all right.
It's like sort of people who laughed at me. Not you.
What do you guys give for the approximate height of said Eiffel Tower? 300.62 meters? Is the Eiffel Tower really about 1,000 feet tall? Oh. I've been there. I don't remember. I didn't read
Did
the
you
plaque.
go to the top of it?
Yeah. We waited in line. You could go up all the stairs and stuff like that. There's a couple little elevators you go up. But most of the time, you're just taking up stairs and just going up to the top there. They have that really cool observation deck that you walk through, and then you can go up further and all that. Because then the Eiffel Tower overlooks the main Champs-Élysées, like that. Towards you look one direction, you've got the Louvre, and then the other direction is like the, what is it? Something else. Something important. I don't know. But yeah, Paris is really cool. Not so bad?
Were they mean to you,
No.
French people?
No. No, I said I was Canadian, so they were fine. I talked like this, eh? Every once in a while I said eh. So that way they thought I was Canadian, eh?
Wait, are you being serious?
Yeah. Oh yeah. French people don't like Americans all that much, but so if you say you're Canadian and you throw the word "a" in there every once in a while, because like a Canadian does, you'll be fine. Eh? If you ever travel, I don't know if your generation travels a lot anymore, but what a lot of people did for the people that you would stay in like youth hostels and stuff like that when you're traveling around Europe, a lot of people would stitch the maple leaf onto their backpack. So that way people thought they were Canadian, not American. Even though you'd have an American passport, but nobody really cared at that point. Yes, sir?
I've been in this class for like months, and that's like the most like important thing you've ever told me.
About what?
About
Act
anything.
Canadian?
About anything, like math or anything.
Really?
Salty.
Act Canadian if you're in Paris? Merry Christmas. I'm glad that it took till almost March to give you some validity to the rest of your life. Way to go, Trash.
Hey, now we know how tall the Eiffel Tower is.
There you go. All right, let's do another one.
Oh, you're right. I think. It's not drawing I wrote that on like 3 tests that I've taken.
No, romance.
Just like as been going to course.
Not very well. I've been practicing.
It's true. All right. Also, you might remember that sometimes angles of elevation, depression style problems
I could
can
give you a
become
special finger right now.
complex. You can throw rather a little bit more complex style problem to them pretty quickly. A backpacker notes that a certain point on level ground, the angle of elevation to a point on top of a tree is 34 degrees. After walking 50 feet closer to the tree, the backpacker notes that the angle of elevation is now 54 degrees. Find the height of the tree.
Oh.
Wait, we just use the
What's that?
We just use the
You would do x minus 50 for the thing, and then.
Well, let's think about what this is going to look like. First of all, we have to have a tree.
Let's see it, Mr. Murphy.
Level
I
ground.
had to be up at 4.
It's like a piece of broccoli if you really squint hard. And then you have a backpacker.
So it looks like 2 little triangles inside of each other.
Right, so what we wind up doing is we have to set up a way of figuring this out.
Well, you don't know how far it is from the beginning, but you do know that it's 50 yards less. Or 50, after walking 50 closer to the tree, 50 what?
Oh, we use the woodsman
Why are we using a woodsman?
because he's got a backpack.
Can you flip him? Why is he walking
Why
in
is
the
a
opposite
woodsman-
direction?
I'm working on it, please.
Why is a woodsman gonna cut down a piece of broccoli?
Why does it say after walking? It says after walking.
You should have found a
50
farmer.
50 closer to the tree. 50 what?
He's walking towards the
Where's he
tree
looking?
to carve his initials and his girlfriend's initials into the tree to profess his love.
Where's his girlfriend?
Have you not? Have you never used an axe before?
I have.
I have. You can carve something with an axe.
Yeah, only in my family.
Mr. Murphy, why does it say
Fine. He doesn't exist. So there. I'm not having any fun with you anymore.
I think Sawyer should say this joke.
No.
Top of the
I
tree.
didn't say anything about him. I was asking why it says after walking 50
Wait, where did it
closer to
go?
the tree.
I don't know.
That's what I noticed.
Maybe because you're making fun of it.
Yeah.
You said
Sawyer,
that-
thanks for sticking up for me.
You said he used an axe to carve his
No, I
family.
didn't.
What?
No, he said you've never used an axe before. I said only on my family. It's a joke.
All right.
To
So.
scare them on. No, I never used
Do we know how far away the person was to start with from the tree? No. Do we know how tall the tree is? No. So the initial distance from here to here, we're going to call it x.
And then the other one is x minus 50. Even though
Well, what are we going to call the height of the tree, you think?
broccoli.
How about approximation? H. How about h for height? Now they walked 50 feet closer, and where you're getting the whole idea of 50 feet closer, the angle has changed to.
feet.
It says 50 closer.
I've said this whole time.
So now I'm just getting there. So now this is 54 degrees. And if the whole thing was x, you got 50 feet closer. That means this part is now okay. So if you think about it, how many triangles do you have here to work with? Two of them. You have two different triangles, two different angles of elevation. Well, two setups of angles. Okay. So you've got two angles in order to set up. Does the height change for either one of them? No. It's a system of equations. Look at the original equation. The original one. If I look at my original angle of elevation, it would be the tangent of 34 is your height over your distance. You okay with that? So the tangent of 34 is your height over distance. If I do the other triangle is the tangent of 54 is your height over your distance. What do those two equations have in common with one another? They both have h in them, don't they? So what that means is that I'm going to get both equations and get h by themselves. Because if I get h set equal to h by itself, can I set the tangent portions of them equal and solve for x? That's the idea. So let me take these two on a separate sheet here real quick.
Where did the woodsman go?
Made fun of him.
He's right.
Thank you.
You're welcome. So he's going to watch us do this. And he's, as you can tell, he's rather stern and kind of iffy. If we screw this up, he might have to ask us a question. Oh, is he going to ask us?
Oh my god.
All right, anyways.
He looks so like. He looks like me right now.
So you get that one. Tangent 34 times some value of x is the height. On the other side, I get the x minus 50 times the tangent of 54 is equal to the height. Which means I have the same thing equal to both sides. I have both equations solved for h, which therefore means I can set them equal to each other via substitution. So x times the tangent of 34 is x minus 50 times the tangent of 54. You okay with that? All right. Now, do you guys agree that tangent of 34, tangent of 54 just be some crummy decimals?
Yeah.
Okay. So let's move crummy decimals together, and let's move the funky the other parts together as well. It's all being multiplied, so that means I have to divide things back and forth. So what I'm going to do is I'm going to divide both. First of all, divide both sides by the tangent of 34. So I'm going to have x is equal to x minus 50. Excuse me. And then it's tangent of 54, tangent of 34. This is still being divided by all that, but what I'm doing here is think of it as, 3 divided by 2. It doesn't matter where it goes. I'm just moving to the side because I'm going to move this junk back over. And there's a reason why I'm doing that. Because now I'm going to get some crummy decimals. So in my calculator, what I'm going to do is first make sure I'm in degree mode. Good. I'm going to take the tangent of 54 divided by the tangent, oops, I forgot to close my parentheses. Tangent of 54, close it, divided by the tangent of 34, and hit enter. I get that crummy decimal. All right. That crummy decimal, move this up a bit here. Yeah. Is that. Okay. Excuse me. Now, the way that I set this up is I kind of set it up in a way that was longer than it needed to be, because I wanted to show you guys how you can get the decimal value and leave the variables on one side and move stuff back and forth. So what I want to change this now to is bring this back up there. So I'm going to have x equals 2.04 times x minus 50. Yes, ma'am.
How did you, after you divided x tangent 34 divided by tangent 34, what did you end up with, like, x is, like, I'm confused.
What happens here, before I did these two steps, I brought this over to here. So this just gives me some crummy decimal.
Yeah.
That's just some number. I don't know what it is. So it's still that chunk x minus 50 times some crummy
And
decimal.
then wouldn't it just be x, though, on the left?
Over here, it is. But what I did then was I moved this back just so I could show you guys that there was just going to be a number here to begin with. Technically, I didn't need to move this back and forth. That's that extra step that I didn't need to do. Because what happens now, once I divide this out, I'm getting 2.04.
Yeah.
And I have to distribute that back to this part anyway.
So then, why didn't you, like, subtract it? How did it end up, like, dividing?
It's multiplied.
So you just divided by
Yeah.
x minus 50?
Yep, I just divided, just to move it out of the way, just show you guys that I'm just dealing with a number, some crummy decimal first. And then I just go, that's why I moved it to do the decimal, and I put it back. That's that extra step that you really don't need to do, but I was just trying to, I thought it'd be easier for you guys to see it if I did it that way. So now all I have to do is distribute. So I'm going to have x equals 2.04x minus 102 point. Just 102? Oh, okay, cool. So now it's a two-step equation. Subtract 1x, add 102. Divide it out. And what do you get? Tall has said tree. 98, I was gonna say it was 98 something?
0.0769.
98 point,
0.0769.
there's your height. 98.08 feet. Using the system of equations with the law of, not law of science, excuse me, we haven't gotten that far yet. Using the system of equations with angles of elevation or angle of depression, it does happen from time to time. It's not overly complicated. Well, but the idea is that you understand where did all those values come from. And it comes from being able to draw on a diagram to make it make sense. Okay? I'm trying to think of another. I think that's good enough.
Wait, Murphy, when we found x, was that actually the height of the tree? Or was that just on the ground?
Oh, that's the x value for us in this case was ground. That's ground, sorry. That's ground. And then you just substitute back in to get, multiply that by the tangent of 34 to get height. Let me give you guys some of these problems here. What I did was I took some.
You should have looked at my Snapchat.
Oh, that's okay.
The
No.
Russian needs to stop.
Right, because we subtract that. So you need to stop. I just think you're monitoring or something.
Okay, let's do this. Let me explain to you what I'd like to do with this. We're not doing all of this. There's no reason to change it up too much.
No, but like, should we be there at 1 anyway? What the heck?
All right, first thing I need you to do.
It's just like so like it's really time consuming and like really like intense and like things get really like so much it's like yeah, people get like frustrated with each other, especially when it comes to like choreography. It's like one of the
Let me show you guys how this works real quick for that first page. So something we didn't talk a whole lot about right off the bat. If I look at number one says find the tangent of theta if the cosecant of theta is 17 over 15. So you have to draw a triangle. These are all right triangles, obviously. You place theta, and cosecant is what over what? Well, how about this? Cosecant is the opposite, or the inverse of what? Sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So that means that this is your hypotenuse, and your opposite is 15, which means you have to figure out that. It's a triple. Do you remember the triples?
Give me a moment.
Or if you don't remember the triples, what could you always fall back upon? Pythagorean theorem. You can always go back to Pythagorean theorem.
7. Close.
Nice. Yeah, your triples. 3, 4, 5. 5, 12, 13. 8, 15, 17. 9, 40, 41.
I just remember
Is there like a
4 or 5.
Is there a 7, 24, 25, I think? Yeah. So that's how you set those style problems up. Just thought I'd throw a couple of them at you. There aren't any of those like that in your book. There are some like that later on, but they're not as quick. Yes, sir?
How do you do number 2 then? Triple? Because there's not like, that does
What's it over?
1. But how do you know, it could be like 8 over 2.
If it was 8 over 2, then it would be simplified out to be 4 over 1, wouldn't it? Yes. Ratios are always written in the most simplified form.
wait, it's cosecant and cotangent. What's the cosine? Wait, so is this
Cosine is secant. So cosine and secant refers to.
so it's
Your answer would be 15 over 8. Yep.
secant, cosecant, and cotangent?
Yep. No, it's cosecant, secant, cotangent. Okay. And then we'll worry about this back page. I don't know. They're not as difficult as I thought I wanted them to be. So basically, these problems right here, these are just the ones right out of the textbook, and I just figured it'd be just as easy because I wanted you guys to do some of these, find theta values. I figured it's just as easy just to put them on the back of that sheet. If you want other practice ones, you've got this one that has the answers on the bottom of it. And if you want to just do this, by all means, it's fine.
Yeah.
We might come back to that. I eat good breakfast and I work out regularly, so I'm able to pull papers apart. It's hard to believe, but you can do it too.
I don't know which one's like theta.
You place theta. Remember, theta always looks at it opposite.
Oh, you're finding
Theta will always look at its opposite.